Can you say something?
Yes,
No? It's not working? No?
but you can see me.
Yes, I can see you. Oh, now we can hear you, but very,
You do hear me?
Yes, a little bit now, sound is coming.
Okay.
So, is this a case that we can increase the volume a bit? I don't know. Oh. Do you have a headphone or something? Probably then we can hear properly.
Yes, just a minute.
ওই একটা মাঝামাঝি কিছু একটা স্ক্রিনটা কোথায় গেল? স্ক্রিনটা কোথায় গেল? না না না, শুরুটা মহাদীপ, শুরুটা। আচ্ছা, তুমি স্টার্টিং বলে দাও, যে মহাদীপকে ডেকে নাও। বাট কিন্তু এখানে স্ক্রিনটা কোথায় গেল? যারা ছিল তারা কি আছে? এটা কি নেট নেই? হ্যাঁ, ইন্টারনেট নেই তো। দেখো নেট কানেকশন করা ব্র্যান্ড কানেকশন আছে, নেটওয়ার্ক সমস্যা আছে। Jack, can you please speak a bit? We see that whether we can hear you. No, still we cannot.
This celebrated student of the respected Alfred Tarski, big name in mathematical logic, Professor Horogori Narayan Gupta from Canada, who happened to visit Calcutta, and he gave some lectures on logic, which Professor Chakraborty at the time very diligently took notes of. And I must confess that those notes actually he used for his logic course, for which several of us took as students. And later, when I became a teacher, I also used those notes. So, I mean, they were so well written, and of course, not to say about the speaker himself, Professor Gupta, how well he motivated the attendees. So, the journey began there, and slowly it kind of proliferated across disciplines. So, not only mathematics faculty and students, but people from philosophy, physics, computer science, they all joined, and you can imagine that how exciting the journey was, because these were people from different disciplines speaking and writing different languages. So just to understand the different languages, to appreciate what is being said in the other, itself requires a lot of willingness and also effort. So the participants in this logic circle very nicely did, and that journey did not look back. Students of all these faculty members who started the journey, and their students and so on. So this is kind of propagated not only in India but outside. And the participants have, how they contribute in the proceedings of the logic circle are in two ways primarily. There are weekly discussions as well as these annual seminars. So the weekly discussions, the participants choose some engaging topics which all the participants generally would be interested in, could be from any discipline, as I already mentioned. And the annual seminar focuses on different topics which would be rooted in the interests of the participants of the logic, or members of the logic circle. So these have been great motivators for the researchers within the logic circle, as well as outside. The participants who came from outside to attend the annual seminars I know personally have gone back very enthused about not only the subject but the different kinds of work that the speakers and the members were doing. So that brings me to the diverse topics that the members of Calcutta Logic Circle have been interested in, have been contributing in. So as I already said, these are not only in mathematics, not only in mathematical logic. So within mathematical logic, you have relationships between logic and algebra. You have what we are discussing today, paraconsistency, looked at from different approaches. You have philosophical logic, you have logic interface with computer science. So different, very diverse topics of research the members have and their affiliates have been engaged in. So of which today we meet to discuss one of these directions, which it so happens that several of us have gotten into, namely paraconsistency, from different angles. So you will be hearing contributions from different approaches into paraconsistency, both philosophical as well as mathematical, in this workshop. So I am delighted that the members here who are in Calcutta have taken up this initiative, and the Ramakrishna Mission Narendrapur has given so much support to host this event. So we are really grateful to them for providing this support and venue. So without which this wouldn't have been possible. We also thank the online participants who have made time to, and will be making time to attend this two-day proceedings. I really wish all the best, and I hope that we shall enjoy each of the lectures and have a lot to take home, about. So thank you.
Okay, so now Professor Mihir Chakraborty will give an introduction to the kind of work that is being done in India in the field of paraconsistency.
ঠিক আছে তো আমার তো কিছু করতে হবে আচ্ছা আচ্ছা এরা কি শুনতে পাচ্ছে যারা আচ্ছা okay good morning everybody this is really a very unique event in the sense that researchers of paraconsistency in India, though a very small community now, have come together to celebrate or to pay homage to Professor, to the founder of paraconsistent logic or paraconsistency in general, Professor Newton da Costa. And this also gives an opportunity to present the activities in India, which is actually, of course, started a bit late, to the community, world community. So really the purpose of this meeting is at least twofold. One, to pay homage to Professor Newton da Costa, who passed away perhaps last year. And second, to inform the world community of paraconsistency about the types of activity that go on here in India. So with this introduction, first I apologize. Okay, change no, go back. First I apologize. First I must say that these slides are not very well prepared. We didn't have much time, so there are plenty of mistakes in it, so kindly excuse us. By us I mean myself, basically, primarily, and also my assistant, I was assisted by Pulak Samanto, who was a former student of mine and now a faculty of this college, and who is one of the main organizers of this conference. Okay. So the first slide says that the 5th World Congress on Paraconsistency was held in Calcutta, India, at Indian Statistical Institute in the year 2014, February 13 to 17. I remember once Professor Jaibs Berjou actually sent me a mail and wanted to talk to me. So, and over telephone he asked whether it is possible to organize the World Congress, 5th World Congress in Kolkata or not. And at that time I was connected with ISI, Kolkata. So, but I didn't think that it could be done in ISI. So I was trying here and there. finally, I got some friends in ISI, of which I must name Kuntal and others, some others, and we approached the director, and he, at that time, Bimal Roy, and he kindly allowed us, to this. The main problem was that nobody in ISI was working in paraconsistency. Even nobody did know the name paraconsistency, the word paraconsistency, except myself. I knew a little bit of it. I worked a little bit on this topic. So I was interested very much. But it was the International Congress, and so really not too many people from ISI, the faculty members really participated. But some definitely did, of which one is Kuntal Ghosh, and another important faculty member, important in the sense that he came from the mathematics department, is Professor Rana Borua. So I remember I take this opportunity to really convey to them that starting from that Congress, we have come up to this. And so they should not think that they have wasted their time giving support to us. Well, so after that, the proceedings were published by Springer. Its name is New Directions in Paraconsistent Logic. It was edited by James Baiju, myself, and Soma Dotto. And it was graced with a foreword from Professor Newton da Costa. Okay. Okay. So this is the book which came out. And now in the preface, there was written this thing: in India, paraconsistent logic is still not very well known, but people do have interest in the subject, and a few researchers have taken it quite seriously. It is quite true. It was quite true. Because that time, I don't know whether anybody except myself and Shoma really worked a little bit on it. So let me see. Okay. Another thing, this slide shows a paragraph from Professor da Costa. I read this. This volume is valuable not only due to the technical works it includes, but also because it contributes to show the meaning of paraconsistent logic and its connection with other domains of knowledge. It also testifies to, you can see the mistakes, it also testifies to know maybe how paraconsistent logic is spreading around the world. The 5th edition of this Congress having been organized in India. So this was really a very good, I think, attitude, gesture from the founder of the subject. This is, all of us know, Professor da Costa. I met him once in Brazil, and that was really very exciting meeting, but very short-lived. We spoke for maybe 10 minutes at most. He was surrounded with many people, and I sneaked into it and had introduced myself and had some discussion with him. I mean, talks. Okay. Anyway, he was very nice gentleman. Now, as mentioned in the earlier slide, that in the introduction says that before 2015, there are not too many publications. These are two publications. This is one of them. It was published in 2008. It is Axioms of Paraconsistency and Paraconsistent Consequence Relation. It's by Shoma and myself. The abstract is this. In this paper, axioms of paraconsistency as well as those of paraconsistent consequence have been introduced and their equivalence established. Actually, the idea, in fact, we were at that time deeply engaged in the relationship between consequence and consistency issue. Classically, it is, there are a lot of work done on this area. And we were doing it in our own research interest, that is theory of graded consequence. There we were working on this equivalence of this. And so, since it is paraconsistent, here things were becoming quite complicated. So, but we were really interested to see how could we define the notion of para-inconsistency, what does it mean, and paraconsistency, and whether it is possible to make some kind of bridge between the two. Well, so that was in this paper. The other paper was the negation and paraconsistent logic. It was published in 2011. And here also, actually, this same project was further, yes? So, do it. Take a all right. শুনতে পাচ্ছে না, এটাতে শুনতে পাচ্ছে। ও তাহলে কি হবে সেটা? মুশকিল হবে। শেয়ার হচ্ছে কিন্তু বলছি যে মানে কানেকশন এত ক্লিয়ার যে মানে কথা ঠিক করে শোনা যাচ্ছে না, স্লাইড ঠিক করে বোঝা যাচ্ছে, দেখা যাচ্ছে না, মানে যেটা বলছি কানেকশন কি করবে, ওরা কি করবে কানেকশনটা জানি না। ওদেরকে জানাবে কি করে? হ্যাঁ, অ্যানাউন্স কি করবে বলো তো? এটা অ্যানাউন্স করতে পারো? বলে যে আমরা একটু ইয়ে করছি।
To all the audience who are attending our workshop online, so there is a message that probably due to the bad internet connection, you are unable to hear and see the slides properly. So we are trying to solve a bit the problem, and then we will resume again in a couple of minutes. So we are trying to fix it. So bear with us for 2-3 minutes. Can someone tell us that whether you are facing the same problem? So can someone speak? Hello? Can someone kindly speak whether you are facing the same problem from at least 2 audience?
It's audible.
Is it audible?
Yes, sir. It's audible.
Clearly audible?
Yes.
And also, can you see the screen?
No.
Screen not visible properly.
No, like from the beginning, the screen was not visible.
No, it was visible before. If you share that one, yeah. Now it's all right.
No,
It's
but
all right now.
previous to this slide, could you see?
Nothing. I'm nothing.
No,
now.
no, no.
Oh. Okay, so now is it visible?
Right. It is visible now.
And you can hear us properly.
Right.
Okay, Shantan, can you hear us and see the slides?
Yes, sir. Yes, sir. I can hear you as well as I can see the slides.
What about Shantan? Shantan, can you hear us?
হ্যাঁ স্যার শুনতে পাচ্ছি
Okay.
শুনতে পাচ্ছি
And you can see as well, right?
হ্যাঁ স্ক্রিনেও দেখতে পাচ্ছি
Okay, okay, okay. Sir, আমার মনে হয় যদি আপনি একবার 2 মিনিটের জন্য একটু পেছনে গিয়ে আরেকবার যদি একটু আগের সাইডটা যান। হ্যাঁ।
আচ্ছা এইটা বল দেখো
হ্যাঁ।
এইটা দেখতে পাচ্ছে কিনা
Is there anyone who saw this slide before?
Yeah. We can see it. We can. See
Oh, okay. That means okay. So, well, so it's okay.
But we have not seen these slides. We have seen only first 2 slides, I think. After that, nothing was visible.
কি বলছে আপনার that first 2 slides, okay. So maybe in that case I repeat. Do you hear me, Kamalika? Was it Kamalika?
Yeah, yes, sir.
Do you
I can-
hear me?
হ্যাঁ স্যার শুনতে পাচ্ছি স্যার
আচ্ছা তাহলে ঠিক আছে, let me see. So do you see this slide?
Now I can see, but we have not seen this.
Okay, all right then. Okay, actually what I did, my first slide was about
Yeah, these
this
2
thing.
slides
This
were-
was the first slide that it says that the first 5th World Congress of Paraconsistency was held in Kolkata, ISI, and then this was the cover of the book, and then this was from the preface, and next this is from the foreword of Professor Da Costa, and Professor Da Costa's picture, and then the 2 papers that were published before 2015. The first one is this, and the next one is Negation and Paraconsistent Logic. This was in 2011. Now, Kamalika, I ask you, do you hear everything and see everything?
Yes, sir. Yes.
Okay, all right then. All right. কি চাইছো?
একজন কেউ জয়েন করতে চাইছে।
ও
কোথায় যেতে চাইছে সেটা বলো।
যেটা যেতে চাইছে কে? হ্যালো।
Okay. All right. So now, however, starting from Rapset angle, a bunch of logics had been developed in transactions of Rapset. Developed by Moha Banerjee. I think you missed that name. Moha Banerjee and Martin Bander and myself. So there are 3 persons. You see the reference there. You have Bander M.W., Banerjee Moha, and Chakraborty Mihir. So this was something. This was something completely different. Our intention was not to do paraconsistency, but we were doing something called rough modus ponens rule and rough consequence relation. And it was Martin Bander who pointed out first that what you have done, we developed some logics, and he pointed out that what you have done is Jaskowski's discursive logic. Later, Moha and Mohua perhaps single in one of our own papers actually studied this further, and now we know that the logics that were developed from the standpoint of rough set theory, which we called rough logics, and the rules were called rough MP rules, modus ponens rules. Of them, two were really equivalent to Jaskowski's systems D2 and J. Now, there is a controversy about whether D2 and J are different or not, although their formalisms are different. But anyway, so that these systems, D2 and J, these are in some sense considered as the logic. So in that sense, we can say in India, these are the seeds in some sense that can be considered as a kind of beginning. Well, now many important researchers or sort of founders of paraconsistent logic visited us. For example, Graham Priest, James Beju, and Joe Marcos. I mean, all of them came to Kolkata or for various reasons, particularly in the programs of Calcutta Logic Circle, and their presence also, I remember Graham Priest also visited Calcutta University and gave a talk there. Now, from these people, the logic community here in Kolkata, they knew something about paraconsistent logic. So we should also recognize that. Now this is a slide which shows another paper which is in the proceedings that of the 5th Congress. This by Shoma Datta and myself. It also it further develops the same idea, where very nicely, very accurately, it was realized that the notion of consistency or inconsistency is not a sort of absolute kind of thing. It is a relativized with respect to the formulae. So with respect to the notion is not it is not a unary predicate, it is a binary predicate. So it is a consistent or inconsistent relative to some formula. So we can say a set and a formula is consistent, or a set, a formula is inconsistent, or something like that. Okay, the idea was developed. I will not go into the detail of what is done there, but I will just present the kind of things that was done. This was also in this same book. It is by Saurabh and myself. It is a paraconsistent logic obtained from an algebra valued model. You will see later that Saurabh has continued and worked extensively on these algebra valued models, and which really gives an alternative account of paraconsistent set theory. Here in our audience is one of the main proponents, main researchers of paraconsistent set theory, that is Jack Weaver. We are very happy that he is present here. And so Saurabh's activity on paraconsistent set theory went a little bit in a different direction. Well, since then, Saurabh with his collaborators continued his research in this field consistently. His work till date includes the following publications. So I will now go a bit quickly. You can see the in the same year with Benedict Lowe, he published generalized algebra valued models of set theory. We know Boolean valued models of set theory, that is quite well known, and also Hating algebra valued models for set theory. So in the same line, but here they followed Takeuchi, Titani, and this. As far as I remember, this work was done when Saurabh was working as a PhD scholar. So this is included also in his PhD thesis. Incidentally, Benedict Lowe was his co-supervisor. Now you can see the next, all these are connected. Saurabh's work, these are on algebra valued models of paraconsistent set theory. So those who are interested in set theory emerged for paraconsistent logic or consistency. They will be definitely interested in these works. So here he studied ordinals. Then again ZF between classicality and non-classicalities. I have just seen the abstract. It is quite interesting and important also, I think. It is Saurabh and Giorgio. This one is again constructing illoyal algebra valued models of set theory. You can be interested in the word illoyal, and you'll get the definition there. Well, now next one is all these Saurabh's work, non-classical foundation of set theory. So here, and you see the publications also are in very important journals and places. Now this next one is the independence proof of non-classical set theories. It is by Saurabh and Giorgio. Now ideal objects of set theory. This is also very interesting notion. This is also a very interesting notion. I think apart from its technicality, it, as far as I have understood or I have seen, it has strong philosophical significance. Philosophy of set theory. Those who are interested in philosophy of set theory, they will definitely get lots of important things to think over in these notions. Next one is independence proofs in non-classical set theories. That's quite important. Now, in the year, so that was independently done by Saurabh along with his other collaborators. Now, in 2022, a handbook of logical thought, a handbook of logical thought in India, that's the full title. It came out by Springer, India, and it was edited by Sundar Sarukkai and myself. In that book, I requested Saurabh and Soma to write a joint paper in showing the development of paraconsistent logic in India. So to represent that part. So they did this, and so you can understand from the title, consequence and consistency, interderivability, and paraconsistent set theory. So it had, as far as I remember, two broad sections. One section containing the consistency or inconsistency, consequence, relationship part, and the other was set theory part. And this is a kind of kind of summary of what was done up to that time by Shoma and Saurabh. Okay, I skip this, the abstract now. Then Shoma Datta's next involvement in the area, again noticed in recent years, because of her association with Mahua Banerjee and her PhD student Bidhan Shah. Sorry? Oh yes, sorry, that's mistake. It is a joint, other supervisor of Bidhan is Shoma Datta, so it is under joint supervision. Sorry. Here you see we note two publications. It should be two papers. One, the second one has not yet been published so far, but I think it should be the second one. The first one is okay. This one, this one. Okay. They have done interesting thing. It is in some sense continuation of Soma's work. I mean, there in that work, she developed a picture, a big tree with many leaves, of which the tree was a tree where at the leaves can be associated a paraconsistent logic. And most probably, I think in the talks today or tomorrow, they will deal with that thing. So what is there in this Bidhan's work is that there were plenty of leaves of the tree not supported by any known paraconsistent logic. So they have been able to fill, I think, almost all here. You can see the significance of the diagram lies in that any logical system satisfying all properties in a branch of tree would have a non-explosive consequence relation such that the notion of consequence and relativized inconsistency are interdefinable. Finally, here you see, here in this study, the remaining branches are taken up and logics are formulated so as to be placed under them. So I, as far as I have heard from them, that almost all the leaves are now have some flowers there. So they have some, okay, we'll see, we'll wait for it. It is, in my opinion, it is one of the most interesting development because we know that there can be many ways of understanding of paraconsistency, and here the study actually was quite elaborate. Shoma's study was quite elaborate. When she developed the tree, and she got I don't remember, maybe 20 or more leaves just hanging at the bottom, of which only 3 or 4 were having some actual examples. Now almost all the leaves are filled. So we now get plenty of paraconsistent logics in our hand. Not only plenty, we have the genesis also. Why is it paraconsistent? What is the root cause of the paraconsistency coming down to this? Okay. Independently, Shankho Boshu and his PhD student Shantan, who is today attending this conference online, were drawn into paraconsistency from totally different engagements, which will be evident from the following 3 papers. Let's see. The first one, of course, I was also connected with this. This was a very, very, very different, direction. It is the restricted rule of inference and paraconsistency. Here are mistakes you see. It's not filled up. But you will get it definitely. There's a published one, so no problem. The main point is this: to which logic there can be an associated logic which can be called restricted. Logic with restricted rule. So this can be done generally. For any logic, you have this, and okay. I think I leave it for Shankho and Vidhan, Shankho to go into the detail. But while doing this, what was observed, that the logic that was developing out of the old logic was a paraconsistent one. So, given a logic, you can construct another logic which is paraconsistent, and this is one important aspect of this activity. Here is the abstract. Actually, it was actually here from clini logic into intuitionistic paraconsistent weak clini logic. Okay, I think I leave it for Shankho. Perhaps Shankho will discuss about that in more detail. The main point is this: you start with a logic and you get another paraconsistent logic from this, for which you need a kind of dummy truth value. A dummy truth value. That's interesting. But this activity was done by others. Started by others. What is here important is that the new similar logics were developed. One was PPRL, and the other one is I don't remember, but the point is this: this logic turns out to be paraconsistent. So there is in some sense, it is a semantic approach, because you have to go to the truth value set. You have to add some dummy truth value there, and you develop the corresponding logic. Okay, I leave it for Shankho to deal with this. Then Shankho and Shanton, they worked in another. This you can see the title: negation-free definition of paraconsistency. One can definitely wonder, what is its meaning? Because paraconsistency really starts with the idea of negation, and is paraconsistent. Something is paraconsistent if it has contradiction, accommodates contradiction, but not explosive. So when accommodates contradiction means automatically negation comes into the picture. But here negation is actually, they are trying to avoid negation. The motivation is universal logic. Shanton is one person who is not interested at all in the algebras. So he is not at all interested in having any kind of logical connective in the So no negation, no conjunction, no disjunction. So he wants to do it set theoretically that way. So just a set with some properties and like this. So how can paraconsistency be defined or understood without any type of connection? It's a very good paper. It is, I think, accepted. No. Yes, without any logical connectives. Now then, here is an explosion again, generalized explosion principle. So explosion principle also without this. I leave all these for. So this is the group around Shankho Shubhra Basu in Delhi. Well, I skip this. Now all these researchers, mentioned so far, are from the mathematics stream. But we have amongst us some researchers from the philosophy stream. The leadership is given by Monideepa Sannal and assisted mainly by Angana Chatterjee, her PhD student. Oh, Javed also is working. Okay, yeah. Okay, I didn't mention that. Okay. All right. So it is a team in Kolkata which is centered around the philosophy faculty of philosophy department, Monideepa Sannal, along with some researchers. They have just started working in it. Now, here are a few examples, 2, 3 perhaps. One is paraconsistency, a non-deviant system. So this is one. It was presented in the 6th Asian Logic Conference in IIT Bombay. I think Monideepa or Angana will say something about that. Okay, I skip this. There's a bit. Okay, here in Monideepa's, here is a mention of Chatushkoti of Buddhist logic and Saptavanghinaya of Jaina logic. This is something which I think should be mentioned here, today, that we have been talking about for quite some time. In many conferences, I personally talked about not Saptavangi, but Chatushkoti. And some other researchers like, say, Graham Priest and others, many others, some others, they also worked on Chatushkoti. Okay, let's see, there is a picture here. So Chatushkoti is this. It's given an X, an entity X, and a property P. The possibilities, the Aristotelian possibility are only 2, X is P and X is non-P. So that's dilemma. Now, here in Chatushkoti, that means in the Indian, ancient Indian, the discourse, there were considered 2 other possibilities. One is X is neither P nor non-P, is one corner. X is both P and non-P is the other corner. Now, the interesting part is this, that we can possibly conceive of, we can possibly think of this left corner that is neither P nor non-P more easily. But X is both P and non-P. This is difficult to accept or to conceive. But there were examples. Their own examples. What I want to say that recently, Professor Belknap, Noel Belknap recently passed away. he also has introduced a four-valued methodology where he has given some other interpretation of these four corners, mainly information, theoretic information interpretation. So maybe four corners may have four different information contents. For example, this one is the corner with the least information, neither P nor non-P. And the right one is the topmost one, which is both P and non-P. It is a full, almost full of information. And these are in the middle. So his lattice, if we order it, it is the least point, it is the top point, and you have, sorry. Well, this I only mention not to make a parallel between these two, but to say that the notion of both P and non-P, which is crucial in paraconsistent understanding, paraconsistent philosophy, was in some sense present in Indian, ancient Indian context. And well, so these are two papers on dialectism. Dialectism we know, which believes that there are actual state of affair which is contradictory. So contradiction really exists in some case, so in some situations. So that is dialetheia or dialectism. I see that they are working in these papers whose abstracts I have not seen much. There is one abstract here, perhaps, no. So we will hear from Angana, or I don't know who will speak about this. So finally, the summary is this. From 2015 onwards, each research in paraconsistency in India has stepped up, obviously. Part of research has been, here is a mistake, part of this research, done so far, done so far will be reported in this workshop. It may be hoped that the present event will enhance another mistake here. It may be hoped that the present event will enhance interest in this field to a considerable extent. Thank you very much. To question answer আছে কি? ও নেই, চলছে না।
আমরাই তো মিটিংয়ে নেই, আমরাই তো নেই মিটিংয়ে।
এই করে হচ্ছে, এটা পুরো এফর্টটা নষ্ট হচ্ছে। এই এতজনকে বলা হয়েছে, আপনারা করতে পারছেন না কেন? এটা ইয়েদের জয়েন করুন না, কোড নেই আমার কাছে। হ্যাঁ, এটা ওরাই বা ওদেরটাই অসম্ভব। সেটা আমি বুঝতে পারছি না, ওদের টপটা তো একই জিনিস হবে। আচ্ছা, ওটাকে ক্লিক করা যাবে, এই মেথিং কোডটা পুরোটা জানেন, পুরোটা দিতে পারবো। ঠিক, এখানে কোড দিয়ে জয়েন করতে হবে। কখন এটা বেরিয়ে গেল সেটা তো বুঝতে পারছি না। পুরো এটা নষ্ট।
আপনি কোডটা দিন এখানে। কোডটাই হবে।
বলছি যে এটা স্যার যেটা প্রেজেন্ট করছিল সেটা দেখতে পাচ্ছিস তো, যে আমরা মাঝখানে যে 5 মিনিট সময় নেওয়া ঠিক করলাম, তারপর আবার দেখতে পাচ্ছিস তো সব না না বুঝেছি, কিন্তু আমি বলছি স্যার যখন আমরা মাঝখানে একবার 5 মিনিট সময় নিয়ে ঠিক করলাম, ঠিক আছে, তারপরে কিছুক্ষণ দেখতে পেয়েছিস তো? মানে 11:40 থেকে পুরোটাই বেরিয়ে গেছে, তাই তো? আচ্ছা, আমরা আবার জয়েন করছি। হ্যাঁ, সেটা দেখছিলাম। ওরা বলছে যে সময় মাঝখানে আমরা ঠিক করলাম, যে 5 মিনিট সময় নিয়ে একটা ঠিক করলাম না, তখন তো আবার সব দেখা যাচ্ছিল, শোনা যাচ্ছিল। তারপরে 11:40 থেকে বলছে পুরো অফ, তারপরে আপনার ইয়ে থেকে বেরিয়ে গেছে, ব্লক করে বেরিয়ে গেছে, বোঝাও যাচ্ছে না যেটা কেউ কাউকে না একটা কাউকে যদি একটা ঢুকে থাকতে পারে ভালো, সেটাও বুঝতে পারছে। এবার তার নেটও তো নেই, মানে নেটও তো কানেক্ট হচ্ছে না, মাঝে মাঝে ফিরে ফিরে দেখতে হবে। এটা তো ল্যানে কানেক্টেড, কিভাবে করতে পারো দাদা? এটার যে ইন্টারনেটটা আছে
ওটা শেয়ার করা যায়, করে দিচ্ছি।
শেয়ার করতে হবে, ওটা দিয়ে আমরা কি একটা জয়েন করে থাকি, আমি জয়েন করে থাকছি। হ্যাঁ, কারণ আমার ইয়ে কানেক্টই হচ্ছে, ই হয়ে বসে আছে।
ওয়ান টু এইট পাসওয়ার্ডটা।
এটা কি হটস্পট ওয়াইফাই অন করবো?
হ্যাঁ, দেখুন ডেস্কটপ,
এটা কি
ডেস্কটপ হাইপেন এমপি সি3 লাস্টে 2613।
এটা করেছি, পাসওয়ার্ডটা বলুন।
1 to 8।
1 to 8?
না 1 থেকে 8, 1 থেকে 8 পর্যন্ত। 1 2 3 4 5 6 7
1 2 3 4 5 6 7 8। এটা তো আরো চাপ করবে
না, আর হবে না ইনফেকশনটা, ওটা অন্য নেটওয়ার্কে ঢুকে গেছিল ওই জন্য।
দেখাচ্ছে খুব মানে
দুর্বল।
অল্প কানেকশন।
এবার দেখুন ইউটিউবটা অন করে দেখুন, তাহলে ইউটিউবটা একবার অন করে দেখুন, বাক্স বুঝতে পারছি।
চলেও যাচ্ছে কানেকশন।
আর কিন্তু বেরোবে না, স্টেবল করে দিলাম, আইপিটা ফিক্সড করে দিলাম, আর বেরোবে না। এটা আইপি দিয়ে দিতে হবে।
এটা আনমিউট করে কথা বলুন দাদা, এটা মিউট করা আছে। হ্যাঁ শুনতে পাচ্ছি শান্তন?
সায়ন্তন শুনতে পাচ্ছ?
হ্যাঁ স্যার শুনতে পাচ্ছি।
এবার কি গ্যালাক্সি A14 ওটা কানেক্ট করব?
এটাই
আরে বাহ,
Okay, so we now break for a brief 10 minutes for tea for the people present here, of course. The people online can have their tea at their own locations. We will join back in 10 minutes for the next talk.
এটা শেয়ারিং
না এটা তো ওইভাবে খুলে যাচ্ছে।
অ্যাডব রিডারে খুলবেন নাকি? চেপে ধরেন, চেপে
Now, mail.
চেয়ারটা কেটে গেল তো, আপনি
আবার কেটে গেল?
মনে হচ্ছে না হাইট করলেন।
Okay, so welcome back after.
শেয়ারটা দেখতে পাচ্ছি না সবাই, শেয়ারটা দেখতে পাচ্ছি না, এবার জিজ্ঞেস করুন।
Okay, to the online participants, is this audible? Can someone please confirm whether it's audible?
Yes, sir.
To our online participants, is this audible?
Yes, sir. Yes, yes.
Okay, so we are audible. Can you see the slides?
Yeah, of course.
Okay, so let's start the post-tea session. We will begin with a talk by Professor Mohua Banerjee from IIT Kanpur and her student Bidhan.
Thanks, Ronko. Thank you. So this is a very special occasion, as I must say that paraconsistency is really not my primary direction of work, but I have got into it primarily because of our student Bidhan, who is a joint student of mine with Shoma, and as Professor Chakraborty already mentioned in his fantastic overview of the work being done in this country on the subject, that Shoma and Professor Chakraborty in fact are kind of the pioneers, so to speak, in this area of work. So, so our intention was to kind of follow up on that work and build on his work for his, Bidhan's work for his thesis. And in the process, what we discovered was this work that Professor Chakraborty also briefly mentioned on rough sets with Martin Bander and the two of us, Professor Chakraborty and myself, that we did on rough modus ponens and rough consequence, that had led to a bunch of logics, a couple of which were paraconsistent. So it turned out from Bidhan's work that we could build on that and get hold of several more. So that is what I will speak on. The first part, I will just give you the preliminaries of the rough set theory and this, the two notions of rough truth and rough modus ponens, on which those logics will be built. So yeah, so let me right away get into this. So rough set theory begins with this very simple notion of approximation space, which mathematically put is just a pair of non-empty domain with a partition on it, so an equivalence relation. And the idea is that, so you, let me right away go to that, the diagram. So you have this domain U with a partition on it. And so the point is that if you now take a general subset of U, let's say X, as is shown here, there is a pointer, right? Lal kota hai. I don't know. Oh, right. No, but it's not visible on the screen. Outside it is. Okay, never mind. All right. So this subset X, one can ask. So the point of this approximation space per se is to reflect at any point of time information that is available on the domain or the objects of the domain with respect to, let's say, some attributes that could pertain to its objects. So when you take a set which is a union of these blocks, that would be said to be completely describable, or as it's termed, definable in terms of the information that we have about the objects. However, in general, if you take a subset X which may not be unions of blocks, you would then have this issue about it not being fully completely describable by the blocks. So, however, then the point is to approximate it with a pair of subsets that could describe it so adequately. So you would have naturally then the union of blocks which is maximally contained inside the subset and the union of blocks which minimally contains the subset. So these two are called the lower and the upper approximations. So yeah, so again, mathematically put, you see that the lower approximation is just the union of blocks inside, while the upper is the union of all those blocks which whose intersection with X is non-empty. The boundary is the difference between these. So that the yellow portion is the boundary, the green portion is the lower approximation, while the green along with the yellow is the upper approximation. Okay. So as I already said, the unions of blocks are called definable or describable. So in those cases, you have the empty boundary. And those blocks themselves are called elementary sets. So a definable set is a union of elementary sets. And obviously that was the intention anyway, that the lower, upper and the boundary are all individually definable sets. And there are some basic properties that come out naturally. For example, it's gone again? Is it?
You have to let somebody escape.
Oh, okay.
Escape. Keyboard escape.
Oh. Okay. So there are these elementary properties of rough sets, or approximations to be more precise, that come out very naturally. So for example, the lower approximation distributes over the intersection while the upper approximation does not. The upper approximation distributes, on the other hand, over union, and those are naturally consequences of the fact that the lower and the upper approximations are dual of each other in terms of the complement. So the two other fundamental notions that come up again very naturally are the notions of inclusion and equality in this perspective. So since we do not have complete information about the objects on the domain, we just have those blocks here giving us the information. So it's kind of, we are looking at through a spectacle the domain and its objects. So you cannot any longer talk about crisp, so to speak, or ordinary classical inclusion or classical equality in the perspective of that information, which I'm going on reiterating. So on the other hand, so every subset X in general is being described by its lower and upper approximations. So it is then natural to talk about rough inclusion of two such subsets, which is defined in terms of the inclusion, classical inclusion of the lower and the upper approximations respectively. So you just extend it to the notion of equality and you get the notion of rough equality, which is really at best what you can say about two sets or rough sets or sets in this approximation space being equal to each other. So rough sets as such have got several definitions over the years, all of which are equivalent to each other. So you can think of any set X. So one of the definitions, which actually Pavlak also mentioned in his first work. So I'm not sure I mentioned that this is, the entire theory is defined by Zhisrov Pavlak. And so you can think of any subset X in an approximation space to be a rough set, okay? And on which you look at these approximations and their properties. So if those of you familiar with modal systems would already have sensed that this is kind of hinting to modal, a logical counterpart of this entire theory would seem to be or be indicative of being grounded in a modal system where these lower and upper approximations would be pointing to the two modalities. So in fact, that's where I'm going next. So you look at the system S5, so not only normal modal system, since we talked about approximation space being a domain with an equivalence relation, so the moment you talk of modal systems, you think of S5 because its Kripke frame is exactly that. So you look at the Kripke semantics for S5, then you connect it back to rough sets and its terminologies, you see that you take any formula in S5 and its interpretation then is nothing but, in a Kripke model, would be nothing but the lower approximation of that, of the interpretation of that statement, right? So similarly, so L and M, there are other approaches which talk of box and diamond, so I'm just adopting this L and M instead. So, so on the other hand, if you talk of the interpretation of M alpha, that's nothing but the upper approximation of the interpretation of alpha in the approximation space U, R. So if you go to the notion of truth, then standard model classical systems, you will just say that alpha is true in this model provided the interpretation covers the whole domain. So in this, so this is the basic connection that I would draw between S5 and the rough set terminologies. And now if you look at rough equality, and the fact that L is being translated as the lower, M is as the upper, so then you notice that if you talk of truth of, of these two roughly equal or alpha, I mean, you can define a connective in this manner, which would be interpreted as, if I have added that, no I haven't. Okay, so which would be interpreted as the formulae alpha's interpretation being roughly equal to that of beta. Because all we are doing here is the moment you have L alpha by implication L beta, note that by implication and conjunction everything is classical in S5. So when I say L alpha by implication L beta and you interpret it in any Kripke model, you are basically saying that the lower approximation of alpha is equal to the lower approximation of beta. So when you have both of these, you are essentially talking of rough equality. And rough inclusion is one direction. So S5's axiomatization, a brief recap of that. So you have classical, the first three axioms, the classical propositional axioms, and you have the modal axioms here, of which the last one is the S5 axiom, and you have the necessitation rule, and of course modus ponens. So just to again connect back the new connective that we noticed, that we introduced about on rough equality, representing rough equality. A simple set theoretic exercise will say that this should turn out to be an S5 theorem, and it does, of course. So what it's essentially saying is that, if you recall the diagram, the figure that I had in the beginning, that it's essentially saying that a set is roughly equal to, you just take its lower approximation portion, add to it the portion from the boundary which is just outside it. Right? So that's the intersection of the upper approximation with the complement. So that those are expected to be roughly equal, and you can prove this syntactically as well. So there are others which may not be so immediate, but this is just to say that these rough set theoretic notions find a reflection in S5 as well. So this brings me to the two fundamental notions of rough truth and rough consequence, which from which we will get the paraconsistent logics. So this fascinating notion of rough truth again was proposed by Pavlak a little time after his original work, the first work on proposing rough sets themselves. So what he's saying is that given this incomplete information or lack of complete knowledge, absolute truth and absolute falsity are not normally achievable, but are achievable only as the limit of our incomplete or current partial knowledge, as he says. So now if you just place it in the perspective of our model system, you are essentially not, contrasting it with the classical notion of truth, where alpha is true if its interpretation covers the whole domain. Instead, you introduce this notion of possible truth. So alpha is possibly true on an object provided X lies inside its upper approximation. And so from that you extend to rough truth of a statement as opposed to classical truth of a statement by saying that whenever it's possibly true on every X. In other words, you are talking of its upper approximation covering the whole domain, not itself. So this naturally seemed extendable to the notion of rough validity, and that's what we did in this is part of my PhD thesis, so with Professor Chakraborty. So the natural question then was that we have this kind of looks like an alternate semantics based on the notion of rough truth. So can we have a logic, an axiomatization whose semantics would be given by this notions of rough truth and rough validity? So that was the start of this investigation. And so the first kind of iteration of this one was that, okay, so we are looking for a notion of consequence which will be such that, suppose I am able to deduce a statement alpha from a set of premises gamma, and suppose I know that alpha's possible truth implies beta's possible truth. And now you have told me that beta implies gamma. So with respect to this new consequence that we are proposing, based on this possible truth, having this notion of possible truth in the background, it should be legitimate to conclude gamma. So this we called rough modus ponens version 1, and one showed later, in fact, with the help of, Bunder's work, that, during the work we were doing with Martin Bunder, that this can be, you notice that these two are both S5 theorems, okay? And this Twiggle turnstile, this is the one that we are looking for. That's a new syntactic consequence. And this middle portion can be actually thrown out, and this is in fact equivalent to what is called R1 here. So if you just look at this system with this rule and admitting all S5 theorems as such, also as theorems under this new consequence, what we obtain is weak completeness. So then the question was, and we cannot get a strong completeness. There are counterexamples. So the investigation, I kind of pursued that investigation and observed that if I add to the rule R1 this conjunction rule with respect to possible formulae, then we get the general completeness. And again, it's kind of, those of us who are familiar with Yashkovsky's J and D2 would sorry, I should not bring J right into the picture right away, but the way the things have been proceeding, moving from truth to possible truth, was basically introducing the modal operator M. So, and every consequence deals with the modal operator. So it was kind of natural to see this relation between the new consequence. It's not unexpected, let's see, but one could derive it, that this new consequence, if you are concluding alpha from a set of premises gamma, in S5, because again these things are hinged on S5, it looks like you are just taking the possible part of S5 and doing consequences therein. So in fact that is what is the case. And this then led us to discursive logic J. Of course, you can immediately see that this is paraconsistent, because if you just go back to the previous slide, you are essentially talking of, you're taking the M, prefixing M with all the premises, prefixing M with the conclusion. And so if you take, let's say, propositional variable P, and you take P and not P, prefix with M, so M of P and M of not P. So possible P, possible not P does not necessarily give us a contradiction. So can hold together, in fact. So therefore it is indeed paraconsistent. And if you look at, so this is where Yashkovsky's thing came into the picture in this context. So far you observed that this logic for rough truth was developed completely independently until we observed that this system of, due to Yashkovsky, which was proposed way back in 1948 as a formalism to represent reasoning during debate or a discourse, where you may have participants who have mutually inconsistent premises. However, you do allow deductions to take place. They may be asserting things which have different statements which have different meanings, and so there may be discrepancies in the so-called discrepancies in the premises. However, you do allow deductions. So that is where, and there's been extensive study, of course, with the person who we are dedicating this entire proceedings to, Professor da Costa and his colleagues, particularly, who have extensively studied Yashkovsky's system and other related systems. So it turns out that J, which is alternately also referred to as D2 in some places, is equivalent to LR, and this L small suffix R is one, you remember, with respect to which we got only weak completeness. So that is strictly embedded inside this logic for rough truth that I just mentioned, and therefore that also becomes paraconsistent. So these two we got as paraconsistent systems through the investigation on rough truth and logics which would have semantics based on rough truth. So this was a parallel thing that we had to the RMP1 rule that I told you about earlier. So rough modus ponens seemed another way of looking at modus ponens in the rough set context, where again notice that we have the Twiggle turnstile is the new consequence we are thinking of, and so you're saying that if alpha is concluded in there through some set of premises, and if beta, from beta we get gamma, however we have the information that alpha is roughly equal to beta, then we should legitimately be able to conclude gamma. So this seemed a very reasonable version based on the notion of rough equality to give modus ponens in this context. And if you, it's a syntactic thing to just, let's say we throw out the gamma, set of premises from that last S5 theorem, then you call this MP. So with Bander started this very fascinating syntactic exercise where we asked that in this rough modus ponens thing, focus on this last S5 theorem or S5 consequence. And so question was that why stick to this rough equality in that part? Can we replace it by different combinations of prefixing L and M to alpha and beta? So you get these 9 different possibilities, of which some turn out to be equivalent in the sense that you have suppose L alpha implies beta is a theorem, then what else is any other of these 9 will it also happen to be a theorem, and conversely. So that is indeed the case, and you don't need to deal with all 9 considering that equivalence, and you have just 5 so-called independent MP rules. So where you notice that we are just playing around with this last S5 consequence. So there are these 5 ones, and we define the logics corresponding to them as we had done earlier for the logic for rough truth. You imbibe, you have, incorporate all the S5 theorems, and you allow consequences with respect to the corresponding MPI rule that we call LRI. And you just extend this. Remember, we had thrown out this gamma, so suppose you bring it back, then you call it plus, a plus system. So for each LRI, you will have an LRI plus. So for example, for MP4, you have this as the plus system where the gamma is back in the picture. All right. So this was our bunch of logics based on the MPIs. So as I think Professor Chakraborty mentioned also in his overview, our focus here was not on getting paraconsistent systems, but to play around with these different versions of rough modus ponens, so to speak. And but it turns out that the fourth one, I mean the logic which is based on this fourth type of modus ponens, where you have this peculiar implication sitting here, M alpha arrow beta. Actually, it's not that peculiar. If you think of J and the discussive implication, this is actually this one, M alpha arrow beta. And so a special case of MP4 is in fact the discussive modus ponens that has been done in Yashkovsky's, or studies on Yashkovsky's logic. So what one can show is that this LR4 is strictly embedded in J and therefore becomes paraconsistent. So just to summarize, I'll just go through this generalization of S5, which is where in the necessitation rule you allow non-empty set of premises. And it's not difficult to show that as far as theorems are concerned, they are identical. But if you allow gamma to step in, then S5 is strictly embedded in S5G. So there are these number of things, of course, which start failing in S5G. And what we were able to show was that this generalized version of S5 is in fact equivalent to where that original one where you had rough equality in the modus ponens part. So that is what we are calling LR rough approx, right? So here, this is what I will end with, where we of course had to finish the whole study with looking at all the relationships between all these logics that came out. So in terms of equivalences and embeddings, what we observe is, so the arrow here is going upward, meaning LR4 is embedded in LR0 and so on. These are strict embeddings. And the dotted lines means they are independent. You can show that neither is embedded in the other. And so what happens is that this entire thing, and you see some of the extended systems also collapse to the original ones. So what happens here is that these three in this part, the right hand part, are all explosive logics, because S5 generalized is, and trivial means the classical propositional, the modalities collapse there. On the other hand, LR4, because J and this are paraconsistent or non-explosive, so LR4 being embedded in this gets to be paraconsistent as well. So this was where we had ended there, giving rise to this portion which is paraconsistent, but this entire part consists of explosive logics. So when we started work with Bidhan, we wondered whether you can get paraconsistent systems following this approach, because that was not really satisfactory as far as getting paraconsistent systems is concerned. And he came up with this nice thought of, remember this was our MPI, where he came up with this thought of why don't we make this also a little more restrictive and focus only on that being an S5 consequence. So this is similar to our first RMP one, which I don't expect you to remember, but that's what we had there. We didn't have a gamma and we had an S5 consequence there, sitting there. So we just changed those and considered this version of it, restrictive version of it, which turns out to be equivalent to, remember that's also what we had said for RMP1, equivalent to, you throw out this middle premise. So, but notice this is true for not true for that rough equality, where you have equality here, rough equality here. So for that we only have one direction, but just to have some uniformity across the board, we took MP bar approx to be also, this, okay? And we extended similarly, like we did for our work with Bandar, putting in back the gamma in, we talked of extending the original one to a plus system. So it just so turns out, which is where Bidhan will take up now, that all these MP I bar systems happen to become paraconsistent. These are not. So that kind of was very exciting to observe, that you're kind of generating through this kind of systematic way, considering different forms of the S5 consequence sitting in that rough modus ponens version, different paraconsistent systems. So thank you. So these are our references for just this talk, and Bidhan will give his own. Thank you.
To the online speakers, can someone confirm that we are still audible and you can see the screen as well?
Yes.
So, can you please confirm that you can see the slides as well, and you can hear us?
Yes, we do.
Okay, thank you. Please, Bidhan.
Good afternoon, everyone. I am Bidhan Saha, a PhD student of Department of Mathematics and Statistics, IIT Kanpur, and I am doing PhD under the guidance of Professor Moha Banerjee and Professor Shoma Dotto. So today I am talking about some new paraconsistent logic based on rough sets. Okay, this is our quick outline of my presentation. So we'll start by constructing some logics, LRI bar, based on our newly proposed rule MPI bar, which is already presented by ma'am. And then we will present some characterization of this theorem, LRI bar. And using this characterization theorem, we will show all these logics are paraconsistent, and then we will show the interrelationship between LRI and LRI bar, After that, we will move toward the semantics part of this logic, and then some extended system will be presented, and finally we will stop by showing some future directions. Okay. So this is our MPI, new MPI bar rules, which have already been presented, and based on this rule, the logic LRI bar are defined as similar as LRI was defined, and the consequence in this logic is defined as the usual way, that a formula is a syntactic consequence in LRI bar if and only if there exists a finite sequence of formulas such that each element of the sequence is either S5 element, either element of premise element gamma, or S5 theorem, or it can be derived by MPI bar rule from their previous components of the sequence. Okay, so now we will present some characterization theorems for those logic except I equal to 5. So this is our MPI for I equal to 1, this is our MP1 bar rule, and this part, S5 consequence part of this rule has a crucial role in this theorem. And this theorem states that if alpha is a consequence of gamma, if and only if either M alpha is the S5 theorem or there exists a beta in gamma such that the expression M beta arrow M alpha is a S5 theorem. So if we notice that the expression of this last part is similar to that the S5 consequence of this part. And similarly, recall that for I equal to 2, the M is replaced, in place of M, there is L. And similarly, we get a characterization theorem for LR2 bar, where M is replaced by L. Similarly, for I equal to 3, there is no such modal connective here. So, and we get characterization theorem for LR3 bar, where there is no such modal operators. So, and these two theorems are presented here. But for I equal to 4, we can get characterization theorem for this logic, but there is some additional part. And this theorem states that if alpha is a consequence of gamma, if and only if alpha belongs to gamma, this is the extra term here. Or it is S5 theorem, or it can there can be beta in gamma such that M beta arrow M alpha is a S5 theorem. Okay. And similarly, we can get the characterization theorem for other two cases for I equal to rough implication and rough equality. And all these proof of these theorems can be done by induction of number of steps of the derivation from gamma. Okay. Okay, and based on these characterization theorems, it is very clear that if we consider two distinct propositional variables, P and Q, and in our S5 logic, neither MQ nor MP arrow MQ nor M of negation P arrow MQ are S5 theorem, then by the contraposition of the respective consequence characterization theorem, we can argue that Q is not the syntactic consequence of P not P in the respective logic. So therefore, all this logic except I equal to 5 are paraconsistent because we don't have characterization theorem for I equal to 5. Okay, so as I mentioned, we don't have any characterization. Condition of this translation entails that all S5 formula can be translated into classical propositional formula by relaxing all the modal operators in the formula. Okay, And the first lemma is already present in the respective paper by Hughes and Creswell, and which state that any S5 formula, either if it is formula S5 theorem, then its translation should be CPL theorem. And based on this lemma, we proposed another lemma which state that alpha is a syntactic consequence of gamma in S5, LR5 bar. Then translation of alpha should be consequence of translation of gamma in LR3 bar logic. And as I mentioned, LR3 bar is paraconsistent. Then by contraposition of this lemma, we can argue that LR5 bar is also paraconsistent. Okay, and this figure shows the interrelationship between LRI bar logics, where the arrow between any two logics represent the lower logic is strictly weaker than upper one, but if there is no such arrow between any two logics, it represents that these two logics are independent. So for example, there is no such arrow between these two logics, so this represents that they are independent. Okay, and this is the interrelationship between LRI, our old logic, and LRI bar. And where the dotted line here, dotted line is represent that relationship between these two logics are still open. So we are not able to find any such relationship between them. Okay, so up to now, we have talked about the syntactic part of this logic. So, but the question arises that how can we think about the semantics part of this logic? So then we define the semantics for those logic in terms of notion of rough sets. And we define semantic consequence relation for those logic into two parts, two cases. So first one is when our premise is empty, and second case is when our premise is non-empty. And for the first cases, alpha is said to be the semantic consequence of empty premise set. That means alpha is valid in LR1 bar if and only if alpha is roughly valid. But when our premise is non-empty, then it should be there exists some beta in gamma such that in every S5 model, whatever we can consider, that upper approximation of truth valued set of beta must be contained in upper approximation of truth valued set of alpha. And yes, and another thing, it is very easily we can see that this definition is a reflection of our characterization theorem. And based on that, it is quite trivial to establish the theorem, sound and completeness. And similarly, this is definition actually for LR1 bar. So similarly, we can define this semantics and sound and completeness for all those logic that have characterization theorem. But for yes. Hmm. Yes.
There should be some element.
For some element.
Is it not always possible?
Is it not always possible?
In this sense,
Mm-hmm.
it should not be, because beta, there is also one condition that beta should come from gamma. Otherwise, it is always possible. You can find a beta whose upper approximation is included in alpha's approximation. That's always possible. But it should occur in the premise. Yeah. Okay.
Okay. Okay, so now we move toward our extended systems. As the similar way the LRI bar, LRI plus was defined. So this is our MPI bar rule, and the extended rule is obtained by adding some premises here, and based on this extended rule, the corresponding logics are defined as similar way. I am not repeating this thing, but from this rule, extended rule, one can easily see that all these extended logic here are explosive. Okay, and similar way we can define the characterization theorem for these extended systems, which divide into two parts. So one case for premise is empty, and other cases for premise is non-empty. For the premise case, for the first case, alpha is a syntactic consequence in this extended logic if and only if M alpha is S5 theorem. But when our premise is non-empty, then if and only if there should be an element beta in gamma such that the M expression M beta arrow M alpha should be S5 consequence of gamma. And the similar way for we can construct this characterization theory for other logics, similar as LRI bar was defined for except I cut 5. Okay, and here also we define the semantics for this extended system based on our notion of rough sets. And in LR1 bar plus logic, alpha is valid if and only if alpha is roughly valid. And for the other cases, alpha is semantic consequence of gamma in L1 bar plus logic if and only if. Similarly, there is some beta in gamma such that in every S5 model, whatever you can take, intersection of all truth valued sets. So this is actually this is the definition is different here from our old definitions. The intersection of all truth valued set of element of gamma and upper approximation of truth valued set of beta is contained in upper approximation of truth valued set of alpha. And this definition is also the reflection of the corresponding characterization theorems. And based on this fact, sound and completeness is quite trivial. Okay, so now we are presenting some relationship all the other logics like LR1, LRI bar, LRI, they are extended system like that. So this is the interrelationship between our extended system, LRI bar plus, extended bar plus, and the relationship between, the interpretation of this arrow is still same. This is the interrelationship between LRI bar and its extended systems. Okay. And this the interrelationship between our old extended system with our new extended system, where this arrow is here new arrow, and it's represent that the lower logic is included in upper one. So we cannot argue that the lower limit is strict or not. And this bold arrow is represent this thing. Okay, so here I am showing some future directions. So as I mentioned, that there are some still open relationship between logics, LRI bar plus, and their extended systems. So to resolve this matter will be the first priority. And since ma'am already mentioned that we don't have any characterization or semantics for the logic LR4 as well as LR5 bar, so it is very important to us to define suitable semantics for those two logics such that they become sound and completeness. And the last directions is related to this paper by Bander, where he had developed some new logics based on notion of rough mode exponents, where S5 is replaced by some weaker logic like S4. So the similar question can be asked for our cases. So that can we replace S5 by some weaker logics so that we can get the similar result or not? This is our under investigation, and we explore and we spend some times for with this matter, and we observe that if we replace S5 logic by some weaker logic, then in few cases our old characterization theorem will hold, and in some cases is not hold. And it's still it's under working. And these are few references that I have used in these presentations. The first one is related to our LRI bar logics, so from where we get the motivation. LRI logics. The second one is related to our third future directions by Martin Bander. And this is another reference by Hughes and Creswell. Yeah. Thank you.
Okay, any questions both for Professor Banerjee and Bidhan? There were no question answered after Mohammadi's talk. So, sir.
No, no, actually to both, I think both of you, I'm still not very clear about the connection between the rough logics, rough mode exponents rules and paraconsistency, except that some of these logics coincide with J or D, whatever. What about, see, we understand paraconsistency in some sense, right? And we also can view these rough mode exponents rules. We understand that also. Now, in some cases, these have some kind of relationship, correspondence. So for some mode exponents rules, you get paraconsistency. What is the reason behind that exactly? What maybe syntactic reason, maybe semantic reason? And what kind of paraconsistency you are really getting here? Do you get my point? Yes.
From the point of syntactic, we can construct all these result, get all these result, and try to give some semantics based on rough sets. Because we got characterization. Why are they paraconsistency? So I am not.
You can answer. Yeah.
No, what we see is that in the earlier case, actually speaking, none of them were paraconsistent, except for that left-hand branch which went up to J and D2. And the lowermost node, which was LR4, which you could put in either branch really. So, but then what Bidhan started with, those mode exponents rules, you may have observed that what we did was, as opposed to the LRI that we had earlier, where that middle premise had the rough consequence. We changed that, we made it stricter and made it into the S5 consequence. And as a result, one of the cases you may observe was just what we began our work with, RMP1, where you remember we took, suppose alpha is a rough consequence and M alpha implies M beta is an S5 consequence. Then you can conclude beta as a rough consequence. So actually the rules that he has considered are versions of those, where you replace M alpha or M beta S5 consequence by different possibilities. And so since that RMP1 logic, our earlier logic, that also was paraconsistent, because that was equivalent to D2. So I am not surprised that, so it looks like S5 is playing some role where you, S5 itself is explosive, but if you just replace the alpha, S5 implication alpha implies beta by different versions there, prefixing different L and M, and that gives paraconsistency. The standard non-explosive symbol.
So if we have alpha, a formula and its negation in our premise set, then it will be explosive.
That means with respect to which consequence?
New. No.
New consequence. That is
Syntactical.
not S5.
No.
Yeah. So with respect to the new consequence, you have maybe you have from gamma you arrive at with respect to new consequence alpha and alpha.
So not like that. So if premise contains a formula and its negation together, then this formula should be trivial. I mean, any formula can be derived from that.
So it means that if you take in the premise simply beta and not beta, or gamma and not gamma, then that doesn't give
Yes.
with respect to the new consequence relation, right?
But what have you mentioned earlier, that so these logics are reflexive, right? So
This is
and
reflexive,
transitive.
yes.
So these two definitions are equivalent. So if gamma, so any formula and its negation can be derived from a
From
gamma,
some set gamma.
then by using reflexivity and transitivity, there is some beta that does not derive from this gamma. This definition and our old definition are both are equivalent.
Okay. This derivation is not the classical derivation.
Yes. No.
So, problem is, I mean, I can ask this question. So you are saying that it is paraconsistent, but not with respect to the classical consequence relation, right? Is it okay?
The classical consequence relation is explosive, but here.
That is paraconsistent, but you can look at it in terms of S5. So basically, in all of these, I mean, actually, this answer, I am very thankful that you asked this question, because I hadn't really articulated it this clearly to even myself. So it looks like to me now that we are just looking at different possibilities coming out of S5 through that S5 premise, S5 theorem premise, and checking that even though S5 is explosive, putting it in this version of this new consequence, because to prove all this we are using S5 properties.
Yes.
So it's giving us, it's throwing non-explosion at us. So that is, I think you understood.
Yes.
What is question?
No, so the general question to.
Important here also, I think peculiar, is that LR5 we haven't really been able to catch in this direct manner. So even though we have been able to show. That is what was the S5 consequence in that? In LR5, S5 consequence looks like what? In LR 5.
LR bar.
5 bar.
It's
Anyway.
L alpha arrow M bit.
L alpha arrow M beta.
Oh,
Actually, that is a little.
Yes. He mentioned that, yeah. Okay, all right. Maybe, yeah. No, yes, I understand the point, basic point I understand. Yes, okay.
We know that there are paraconsistent systems which becomes paraconsistent because the system doesn't allow adjunctive property, non-adjunctive paraconsistent system. Even D2 is a non-adjunctive paraconsistent system. So I don't know whether this rule is included. I just lost somewhere relationship between different logics. So when you were presenting, there was one rule, R2, where it is a not adjunction, a kind of a weak adjunction. Maybe, so these are also playing some role to become a paraconsistent system. I am not sure. Okay.
Any other questions from our online participants?
One simple clarification from Mohua, and that is when you introduce the concept of possible truth, that is you are bringing the modal concept. So will you also encourage in introducing the necessary truth, as you said there is the absolute truth, the word you used.
Actually, syntactically, that will not give us
Anything new, but and that is not also achievable. That necessary truth is not only it is to be presupposed as the limits of our knowledge. Okay.
Any other questions? Our online participants? Our offline participants? All right, so then we'll break for lunch. We will get back at 2:15.
Thank you.